Alright. Alright, so your table should look like this. So I did a column for length, and because the length was in centimeters, I converted the centimeters into meters. So 20 centimeters is 0.2 meters, and I left it as voltage is the same and current is the same. And so for the area, on Excel I did equals pi times, I halved the diameter. I used the diameter as 0.275 as the average, because the average diameter is 0.27 plus 0.28 halved average. And so I did pi times the half of the diameter and then squared. So that was the area. And then for the column where it says V divided by I did the voltage divided by current. So I used equals voltage divided by current in that cell. And then for length divided by area, I did the cell for the length divided by the cell for the area. Now, because the L divided by A was quite large, what I did was that I divided by 1,000,000. So where the column says length divided by area, I did divide by 1,000,000. So now you ended up with 3.37, 5.5, sorry, 5.05, 6.74, and so on. So you should have a graph that looks something like this. But you need to remember that the y-axis needs to be V divided by I, and the x-axis should be L divided by A. I swapped them around. So if you did swap it around, remember that because in the previous one I've divided by 1,000,000, you've got to times it by 1,000,000 back. So for this one, can you see that I used the display equation on the chart? So first, you select the two columns, which is V over I, and I selected the column where it says L divided by A, and then divided by 1,000,000. Those were your two columns. I inserted a scatter graph, and then I formatted the trend line, and that should be a linear graph. This should be a linear graph. And then you display the equation on the chart. And the equation is y equals 1.8942 x minus 0.3835. Now the gradient is the number, the coefficient in front of the variable. In this case, it's x because it is a straight line. However, because the axis is swapped, you've got to do 1 over the gradient. First, we need to work out the gradient. So remember that we divided by 1,000,000. So you've got to times it by 1,000,000 again to get back. And then once you've times it by 1,000,000, it's 1 over the gradient. So because the gradient was 1.89 times 10 to the 6, 1 over the gradient becomes 0.528 times 10 to the minus 6. So the resistivity is equal to 0.528 times 10 to the minus 6.